All right, this video is for the lesson 2.7 homework. Starting today, you're going to need your notes done every day, okay? So the question I posed to my other classes are transformations. That's what we're doing for the next 5 or 6 lessons, okay? The page we're doing today, this is my 8th grade page. This is the page I used to give 8th graders. This is taught in 8th grade. Okay, so we're starting with the easy stuff, rigid transformations. Rigid transformations was your word today. A transformation that preserves the size and shape of a figure. So we can move it left and right, we can move it up and down, we can rotate it, we can reflect it, and it's still going to be the same shape, it's still going to be the same size. Okay, and we're doing the basic transformations today. Basic translation, basic reflections, basic rotations. Okay? Starting tomorrow, we're going to do the high school geometry, reflections and rotations. Okay? So this is kind of the easy stuff, just to refresh from what we did 8th grade year. All right. So number 1 says translate the point 3 units down and 6 units left. Okay. So transformations, we write these rules. We're going to do something to the x and we're going to do something to the y. And this is what you're going to have to do today. You're going to have to write the rules. So your answers on your side are going to look, you know, like these do. But you should be able to copy them down straight from your notes. All right. So if I'm going down, am I messing with the x or the y? Messing with the y. If I go left, am I messing with the x or the y? X. Okay. So translations, here's the rule. X comma y turns into x and then whatever we do to the x. So if I'm going 6 left, would I add to the x or would I subtract from the x? Subtract. So think about what a graph looks like, right? And if I'm going left, those values are getting smaller. So that's kind of how you can tell. If they're getting bigger, you're adding. Okay? And then the y. If I go 3 units down, am I adding to the y or subtracting from the y? Okay. So all I have to do is take the ordered pair that they gave me. This is an x, this is a y, and plug it into that rule. Woo. So x is a -2. I think I need to make a seating chart. Y is a -6. And then everything else is staying the same here. So -2 minus 6 is a -8. -6 minus 3 is a -9. Your answer is an ordered pair because you're taking that point on a graph and you're moving it. 6 left, 3 down. So a visual of this, and you can use, this is the graphing that's you have access to on Google Classroom. So our original point, -2, -6, and our new point, -8, -9. So we can kind of zoom in here where we can see what's going on. So that green, that's our starting dot. I know they're real small. That's the only thing. I wish Desmos would make bigger dots. But to go from here to here, I go left, 1, 2, 3, 4, 5, 6, and then I go down, 1, 2, 3. You can count out translations and make the move, okay? So if you can get them graphed, you can count your movements. All right, next one up. Reflect the point across the x-axis. Here's where these rules come in handy. If I'm going to reflect across, would we say x-axis? Here's my rule. Same thing, we can use this rule to find our new point. So the rule is x comma y turns into x comma -y. Reflections are opposite land. If we're reflecting across the x, we're messing with the y. If we're reflecting across the y, we're messing with the x. It's reverse. Okay? So when we do this, the x value is going to stay the same. Now that negative doesn't mean it has to be a negative number. That negative means multiply it by a -1. which is changing the sign. So if my y is a -8 to start with, it's going to change to a +8. So be really careful with those negative signs, because a lot of kids go, oh look, it's already a negative, and they just write -8 down. So that's not what it means. It's changing the sign. All right, so a visual of what that looks like. 4, -8, 4, 8. All right, here's our points. So here's how I taught 8th graders to do this, okay? So this is my original point here. If we're reflecting across the x, I told them count how many jumps it takes you to get to that axis. 1, 2, 3, 4, 5, 6, 7, 8. Then count the same number of jumps past it. 1, 2, 3, 4, 5, 6, 7, 8. Okay? If you folded this on this x-axis, that red dot would fall right on top of that black dot. It's always going to be the same distance from whatever axis you're reflecting across. So reflections you can count out too. Unfortunately, rotations are just awful. Not a fan of rotations. So first thing I need you to do in your notes, the rule for this one in your notes is written wrong. Here it says -y, -x. It should just be y, -x. So make sure you change that in your notes, because you can use these on your quizzes. FYI, the quiz on Friday, I'm going to take down the online notes. So if you don't have the paper notes, thanks for saying it for me. All right, so our rule for this rotation is x, y turns into y, -x. But let's talk about rotations a little bit here. Because we have clockwise and counterclockwise. Do y'all understand the difference between clockwise and counterclockwise? Maybe? Okay. Think about a clock. The way the hands move, right? The hands move this direction. That's clockwise. And you'll see that abbreviation, CW for clockwise. If you go the opposite direction, that's counterclockwise. Okay? All right. We've got 3 degrees that we turn, 90, 180, 270. So on the coordinate plane, if I start here, let's do clockwise first. If I go 90 degrees clockwise, I'm going to make 1 turn. I'm going to just jump into the next quadrant. Take it, turn it once. Okay? So that would be 90 degrees clockwise. If I go twice, 2 turns, 1 quadrant, 2 quadrants, that's 180 degrees clockwise. If I turn it 3 times, 1, 2, 3, that's 270 degrees clockwise. There's no easy way. You just have to understand that 1 turn. And when I'm talking turns, let's show you guys something. Again, 8th grade. Here's how I taught 8th graders how to do rotations. 8th graders would take this patty paper. They would trace, sorry, pens don't work very well on it. They would trace the axes, and then they would copy the dot. And so if I said go 270 degrees clockwise, they would make 3 turns. So 1 turn until it's all the way lined up. 2 turns all the way lined up. 3 turns all the way lined up. And then this patty paper is so thin, they could punch through it. And then there's where their new point would be. Okay? I will let you use patty paper. I'm cool with that. So the other direction now. So if I want to go counterclockwise, 90 degrees, I'd make 1 turn this direction. But look where it puts me. It puts me the exact same spot that 270 clockwise does. And so the rules are the same. 90 degrees counterclockwise, 270 clockwise is the same rule because you'd end up in the same place. Same with 180 degrees. It doesn't matter. 1, 2. It doesn't matter if you go clockwise or counterclockwise. If you make 2 turns, you're going to end up in the same spot. Okay? So normally it just says 180 degrees because it doesn't matter clockwise or counterclockwise. And then 270, 1, 2, 3. I end up in the same spot as a 90 degrees clockwise. So there's 3 rules we have to know. If you have your notes, then you'll always know them because you can use your notes on stuff. Okay? All right, so here's how this rule works. Here's the rule. Okay? See how the X and Y have switched places? You're going to do the same thing. You're going to take the ordered pair and reverse it. But you're not done yet. Now you look for those sign changes. Oh, look, the second number has a sign change. So if it's negative, it becomes positive. If it's positive, it becomes negative. Not that number has to be a negative. That's just telling you to change the sign. Okay? Then we're actually going to do it. Okay? So translate ABC using the rule. Okay, you got 2 options here. So here's A. Point A is at 3, 2. So I could plug it into this little formula, into this rule. X, 3 minus 4. Y is 2, so 2 plus 2. And then A prime. So when we write a new ordered pair, it's not A anymore. It's A with this apostrophe, and that apostrophe says prime, A prime. And that indicates that's the new point. That's the translated point. So 3 minus 4 is a negative 1. 2 plus 2 is a 4. So negative 1, 4, that's A prime. And it is important that you label your points when you graph them. All right. If you know the rules, though, you can count it out. So if I subtract 4 from X, what direction am I moving? Here's the X. If I'm going to subtract from it, what direction? Left. If I'm adding 2 to Y, what direction am I moving? So I could just count it out. I'm going left 4, up 2. So I can take a point and go 1, 2, 3, 4, up 1, 2. There's my new B, B prime. Same with C. 1, 2, 3, 4, up 2, C prime. Connect the dots. And I translated it. I moved the whole shape according to that rule. Okay? Reflections, same way. I'm going to do one of these points just so you can see. I could use the rule. So I could reflect D. D is at negative 10, comma 7. I could use this rule. X stays the same. Y changes signs. So positive 7 becomes negative 7. So that's D prime. So negative 10, negative 7, sorry, my brain stopped, would be D prime. Or you could count. Start at a point and count. You have to know which direction you're reflecting it, right? So you first need to know which way that reflection goes. Your rules will tell you that X negative Y, I'm reflecting across the X, okay? So I know I'm reflecting across this, so I'm going to count from D, 1, 2, 3, 4, 5, 6, 7, till I hit that axis. And then I count the same number, 1, 2, 3, 4, 5, 6, 7. So again, reflections you can count out. But label your points. It's important. All right, we're going to rotate this one 90 degrees clockwise. So that's this rule down here that we changed. X comma Y turns into Y negative X. There's just no easy way. Okay? So H is at negative 4, negative 2. Okay. They switch spots. So -2, -4. The second number, change its sign. So -2, +4, that's my new H prime. So then I can do J. J is at -2, -2. So they change places, so nothing really changes, but the sign of the second changes. So -2, +2, that's my new J prime. K, so I'll do it down here. K is at -2, -4. So again, my rule, reverse your pieces. The second number changes signs. So -4, -2, that's K prime. And then finally, L is at -4, -4. Reverse them, even though it doesn't change it. Walk yourself through the process. Change the sign of the second. So -4, +4, that's L prime. So why it's important to label. If you don't label it, that looks like a reflection. But if you reflected that, whoop, this point would still be J, but this one would be K. So those names are how we tell what kind of movement it is. Okay? So if that order changes, we know it's been rotated somewhere. If we just flip it, if we can fold it and everything lines up, then it's a reflection. So that's why we label. All right, so your task, all you're doing is you're writing the rules. Okay? So like they're going to look like this. They're going to be different, but they're going to look like that. 4 should say write a rule to reflect a point across the y-axis. Okay, and then you're going to finish up 8 and then use the rule on number 10. We've got about 16 minutes in class. If you've got your notes done, you can probably get this done before the end of class. Okay?